Okay, so here's graphing a y equals a sine of bx plus c function. And if you're in college trig, then this makes perfect sense to you, and I'm hoping to make it even more clear. So this is what you'd be asked. So let's do these things one at a time. Let's take this function, y is equal to 3 sine of 2x plus pi halves, and see if we can't answer these specific questions that we're given. So the first thing I'm going to do is answer the amplitude problem. The amplitude problem is answered by this, that the amplitude is equal to the absolute value of 3, which is equal to 3, right? The period problem is also relatively straightforward. The period problem is this. We take 2 pi over b. This is a, obviously b, so this is a. This is b. Remember, b is not 2x. b is 2. It's the number in front of x. And c is this constant value here. So over b, which is 2, and 2 pi over 2 is just equal to pi, isn't it? That will come in handy later. The phase shift for our function, our function is opposite c, and c is pi halves, isn't it? Over b, which is over 2. The way I would look at this as if it was a complex fraction, because it is. So I would take negative pi halves. Remember, when you simplify a complex fraction, you take the denominator and you bring it up as its reciprocal, so times 1 over 2, isn't it? So we get negative pi fourths here. Okay, so the phase shift is equal to negative pi fourths. All right, let's look at this. Lastly, they always ask you for an interval containing exactly one cycle, and it can be found by solving this equality. We know that sine and cosine usually fall between 0 and 2 pi. So we have bx plus c is equal to that. So all I'm going to do is substitute in those values of 2x plus pi halves here, right? 2x plus pi halves, and I'm going to start solving this thing. I'm trying to find one interval that contains the whole damn thing, right? Okay, so remember, what we're trying to figure out is this x value here. So let's just start moving everything over. So I'm going to take negative pi halves from here. Now look at this for a second. This is two equations, right? It's this equation right here, isn't it? Let me show you this. It's this equation right here, isn't it? And it's also this equation right here. So I'm just going to solve them simultaneously, if you don't mind. So I'm going to add negative pi halves here also, and negative pi halves here. Remember that 2 pi is the same as 4 pi over 2, isn't it? Because 4 over 2 is 2, 2 times pi is 2 pi, right? So when we solve this, we get negative pi halves here is less than or equal to 2x, which is less than or equal to. So we have 4 pi halves minus pi halves is 3 pi halves, isn't it? And then, right, we don't want 2x, we just want x, so I'm going to divide everything by 2. All right, so the middle part is pretty clear. It just gives us x here, doesn't it? But remember that this is a complex fraction again, right? So this comes up as its reciprocal. So this is negative pi fourths here, right? Less than or equal to. Remember, this is this, so it's this. Right, this thing comes up this way, so it comes up as 1/2 here, doesn't it? And it's 3 pi fourths, right? Okay, so let's go back to see what we had here. We had an amplitude of 3. So here's our function. We have an amplitude of 3. So amplitude of 3, so it goes from 3 to negative 3, doesn't it? It says that one interval is from here, from negative pi fourths to 3 pi fourths. No, maybe here. 3 pi fourths. Right? It's a sine function, so it's going to go up like this, back down, and back to here, right? Where this is this here is negative 3, and this is positive 3. Sorry about the scale of this thing. The scale's not right, but this is negative pi fourths to positive 3 pi fourths. Isn't that a distance? This is a distance of pi, isn't it? So that's right, isn't it? Okay, so, all right, hopefully this was helpful.